Thank you for watching this talk on our paper titled, On the Dangers of Stochastic Parrots, Can Language Models Be Too Big? The final authors on this paper are Emily Bender, Timnit Gebru, Angie McMillan-Major, and Margaret Schmitchell. We also want to acknowledge that this work is the culmination of input from several other people who are not able to be listed as authors, and we thank them for their invaluable contributions to this work. Because there are so many authors, we were able to draw from a variety of perspectives and disciplines. So we encourage you to check out the paper for more thorough explanations than we can provide in the time allocated for this talk, and to see the bibliography for references. This presentation is prepared in the first instance for the FAC 2021 attendees. We hope it will be accessible more broadly, but we ask that those who come from other academic traditions and outside academia to please be aware that we assume a shared common ground in terms of technical terminology and review of the research landscape based on the FACT audience. When we started writing this paper, we wanted to take a step back and consider the following, and we invite you to do the same during this talk. Are ever larger language models inevitable or necessary? What are the problems that we are currently addressing using language models, and are there other ways we could address them? What costs are associated with this research direction, and what should we consider before pursuing it? We address a few costs and considerations here, but we are also interested in starting and continuing this discussion as a dialogue between different parties involved in the research. Do the field of natural language processing or the public that it serves actually need larger language models? Are they solving the problems that we identified before? If so, how can we pursue this research direction while mitigating its associated risks? If not, what else do we need? We will bring these questions back up at the end of the talk, and we look forward to hearing your thoughts during the live Q&A session. For now, we'll present some of the topics and concerns that these questions surfaced for us. We give a brief definition and history of language models, followed by the risks that we see as particularly in need of addressing, namely the environmental and financial costs, the unmanageable training data, the current trajectory of research in natural language processing and related fields, and the intersection of abusive language and synthetic data, and the specific harms that can and do occur in that space. Finally, we'll suggest some strategies to mitigate these risks. As a starting point, what is a language model? We use the working definition of a system trained to do string prediction. Here we have some examples where a word is predicted either based on the previous context or the surrounding context, depending on the experimental setup. This statistical approach to string prediction was initially proposed by Dr. Claude Shannon in 1949, but has been implemented for automatic speech recognition, machine translation, and other tasks since approximately the early 80s. Even since the days when n-gram models were popular, we've seen a pattern of achieving better scores through more data and increasing the size of models until scores don't see an improvement, and then the field moves on to new architectures that are able to take advantage of the increasingly large amount of data we have available to us. With the size increase, we also see a change in the types of tasks these language models are used for. N-gram models were typically used to select among the outputs of acoustical or translation models, while neural-derived word vectors replaced bag of word features in tasks involving labeling and classification. Now, the pre-trained transformer models can be retrained on very small datasets using few-shot, one-shot, or even zero-shot learning to perform much more complex generation tasks. We also see the rise of multilingual models that feed language data from several languages or more into a single model. The idea behind this is that data from high-resource languages, particularly English, is used to support lower resource languages in architectures that require a minimum amount of data to function well. The latest architectures combine up to 100 languages in a single model. Most recently, we've seen model size reduction strategies, where language models trained with millions of parameters are reduced significantly using techniques like knowledge distillation as well as others. Please check out the paper for the bibliography and if you're interested in more of the history or these newer techniques. This chart shows the recent trends in language model training dataset size and parameter count. Scaled on the left in orange squares, we see the size of the data set used to train a model in gigabytes. On the right in blue circles, we have the number of parameters. We have a selection of models plotted based on these measures of size according to the date of their first archive publication. Starting from BERT in 2018 with a few 100 million parameters, we see a general trend up to the January 2021 release of the Switch-C trillion parameter model, and we expect this upward trend to continue. So, what are the risks associated with this technology? The first we identify are the environmental costs and financial inaccessibility. The average human across the globe is responsible for 5 tons of CO2 emissions per year. In 2019, Struble et al. Evaluated the efficiency of a transformer model training procedure and found it produced 284 tons of CO2 emissions. They also examined the costs of these models against their accuracy gains. For the task of machine translation, they estimate that an increase in 0.1 BLEU score for English to German translation results in an increase of $150,000 in compute costs in addition to the carbon emissions. To encourage more equitable access to NLP research and reduce carbon footprint, the authors give recommendations to report training time and sensitivity to hyperparameters when the release model is meant to be retrained for downstream use. They also urge governments to invest in compute clouds to provide equitable access to researchers. And so we have to ask ourselves which researchers and which languages get to play in the space and who is kept out. Renewable energy sources are a potential cost mitigation strategy, but they still incur a cost on the environment, particularly in the form of infrastructure. For example, trees are cleared for wind farms, and rivers are obstructed for hydroelectric generators. Using these energy sources for model training also takes away from other potential uses of green energy, such as powering homes. Another potential mitigation strategy is to prioritize computationally efficient hardware, as advocated for by organizations such as the Sustain NLP Workshop. To promote such green AI initiatives, Schwartz et al. Argue for promoting efficiency as an evaluation metric in NLP research. They sampled papers from major NLP conferences in 2018 and 2019 and found that most papers claimed accuracy improvements alone as primary contributions to the field, and none focused on measures of efficiency as primary contributions. There is also a push to document energy and carbon metrics along with new publications to encourage efficient modeling, such as the energy usage reports as proposed by Lotic et al., and the experiment impact tracker code developed by Henderson et al. Finally, in talking about costs and risks, we need to ask who is incurring these costs and risks and who is reaping the benefits. Large language models, particularly those in English and other high-resource languages, benefit those who have the most in society. But marginalized communities around the world are most likely to be negatively impacted by climate change. For example, the Maldives, an archipelagic nation in the Indian Ocean, is threatened by rising sea levels, while 800,000 residents of Sudan were affected by record-breaking flooding between July and October 2020. These communities aren't able to benefit from this technology because language models are not being built or made accessible for Dhivehi and Sudanese Arabic. From here, I'll hand the mic off to Emily to discuss unmanageable training data.
The next set of risks we turn to are those associated with unmanageably large training data. The internet is a large and diverse virtual space, and accordingly, it is easy to imagine that very large data sets, such as Common Crawl, must therefore be broadly representative of the ways in which different people view the world. However, on closer examination, we find that there are several factors which narrow internet participation, which narrow the discussions which will be included via the crawling methodology, and finally, which narrow the text likely to be contained after the crawled data are filtered. And in all cases, we find that it is the voices of people most likely to hew to a hegemonic viewpoint that are also the most likely to be retained. In a bit more detail, let's think about who has access to the internet and who is contributing to these discussions online, and we find that it's younger people and those from more developed countries. We might also ask who's being subject to moderation, that is, who's being pushed out of platforms versus who's able to continue to participate without much friction. Dr. Leslie K. Jones finds that Twitter's moderation practices lead to plenty of cases where Twitter users who have received death threats are more likely to have their accounts suspended than those issuing the death threats. So therefore, you have less participation by people coming from marginalized identities. Another question to ask is, which parts of the internet are we including in these large crawled data sets? Because it's not actually the whole thing. One common starting point is Reddit, another is Wikipedia. And in the case of Reddit, it's not so much the text on Reddit, but the pages that are linked to from Reddit, which are also therefore filtered by Reddit users. If we look at who those users are, within the US, 67% of them are men, and 64% of them are between the ages of 18 and 29. And similarly, surveys of Wikipedians find that very few of them are women or girls. Now, it's not the case that all internet users fall into these poorly representative categories, but we find that when internet users create spaces to discuss things that are less mainstream, for example, the communities that Lazar et al. Studied who use blogs to talk about ageism and aging, those sites are less well connected to things like Reddit and Wikipedia, and therefore less likely to be picked up by the crawling methodology. And then finally, there's this question of what data is being filtered out. Because obviously, when you've scraped all this stuff, you would like to make sure that you are, or at least try to make sure that you are not including lots of hate speech, lots of pornography, for example, in your training data. Unfortunately, this is done fairly naively with lists of words and just filtering out sites that have those words. That works reasonably well to get rid of pornography and to get rid of certain very overtly hateful sites. But it also has the effect of filtering out, for example, LGBTQ spaces where people are speaking in positive ways about their lived experience and their identities. Now, I want to say one more thing about this, which is that the reason we see this as a problem, the reason that we see the overrepresentation of hegemonic viewpoints as a problem, is that people who hold to hegemonic views are more likely, consciously or not, deliberately or not, to use language in ways that is consistent with systems of oppression and expresses those systems of oppression, including things like racism, misogyny, ableism, ageism, transphobia, and others. Another issue is that as you're talking about trying to fix these things, the people in society who are working against these systems of oppression are often doing that work through language. And a language model that is trained on a snapshot of language up to a certain point runs the risk of value lock, that is, of reifying older, less inclusive understandings. And Twyman et al. Provide a very nice example of how this happens by looking at the effects of the Black Lives Matter movement on the documentation of what's happening to Black people in the US through police violence. As a result of the Black Lives Matter movement, there is more production of articles about shootings of Black people. They are written with less of a white gaze, and also past events were documented and updated. If we want our language models to not be stuck in value lock, we might consider doing some sort of retraining or fine-tuning, which seems like a valuable idea, that would also require the kind of thoughtful curation of training data that is exactly what we're advocating for here. All right, so not only do we know that the training data is going to overrepresent hegemonic views, there's also a wealth of evidence by now that language models actually absorb the biases from those views. And we refer you to Blodgett et al. 2020 for a critical overview of what's been happening in this space in NLP. We praise this work. It's very important to be documenting this problem. That's an important first step, but it is not in itself a solution. Furthermore, that documentation requires, in many cases, automated processing steps that may themselves be unreliable. For example, because toxicity detection is more likely to label simple statements of identity as toxic language if they're talking about marginalized identities, and also to label, for example, tweets in African American language as toxic when they are not. Furthermore, if we are going to try to figure out what all the biases are, we need to do the social science work to figure out what social categories are of concern in all of the different locales in which we are working. And that's absolutely going to require broad participation in this technology development, because people sitting in one culture, especially a culture that is on the power side of imperialism and settler colonialism, are not going to be in a position to understand what is going on in terms of systems of oppression that are not directly affecting them. All right. One question that we frequently get asked because of the title of this paper is, okay, but how big is too big? We don't have a number for you because it's not about exact specific size, but rather about practices of curation, of documentation, and of accountability. And our recommendation is to budget for documentation at the start of a project and only collect as much data as can be documented within that budget. The purpose of the documentation is to be able to understand the sources of bias and therefore to be able to perhaps mitigate strategies, mitigate the risks that that bias raises. If you don't have documentation, then you are creating the potential for harm without recourse. The phrase that we like to use to sum up the situation is documentation debt. That is, when you have data sets that are both undocumented and too big to document post hoc. That was one set of risks. There are others. Another category has to do with research trajectories. We would like to focus on the fact that research time is a very valuable resource, and it has been perhaps over-allocated towards large language models and using them to achieve state-of-the-art scores on leaderboards, particularly around natural language understanding tasks. But language models have been shown, when they do well, to do well often because of spurious dataset artifacts. So they're not actually achieving natural language understanding. And furthermore, I've argued elsewhere with Alexander Kohler that they can't possibly be doing understanding because in principle, they've only been trained on linguistic form and don't have access to meaning. In other words, if we take large language models to effectively attack these leaderboard tasks around natural language understanding, are we actually learning anything about machine language understanding, or would our time be better spent in other areas? Another set of risks has to do with the intersection of abusive language and synthetic data. And here, finally, we come to telling you why we've used this phrase stochastic parrots. Now, human-human interaction is co-constructed and leads to a shared model of the world. This is what we learn from linguistics and psychology. When people talk to each other, they are modeling each other's state of mind, and they're modeling a common ground. But a language model is a system for haphazardly stitching together linguistic forms from its vast training data without any reference to meaning. That is, it is a stochastic parrot. The problem arises because as humans, when we encounter synthetic text in a language that we speak, we make sense of it. In other words, coherence is in the eye of the beholder. There's plenty of potential harms that come from this. If you have synthetic text that's got hate speech or other more subtly stereotyping language, then readers who encounter that can experience stereotype threat. They can experience direct negative psychological effects of hate speech. People can also get their own prejudices reinforced and then enact harm on bystanders because of that. One sort of extreme example of that comes from McGuffey and Newhouse's study showing how cheap synthetic text could be used to boost extremist recruiting on message boards. There are cases where a language model makes a machine translation system sound more fluent and therefore more correct when it's actually translated something incorrectly. And so a human reader attributes the wrong communicative intent to the author of the initial language. A fourth category has to do with language models encoding and then being probed to replicate personally identifiable information from their training data. And then finally, language models can also be used as hidden components in, for example, internet search systems, either to produce query expansions or to influence the results without showing the query expansion to the user. And this can lead to harms, again, replicating racism and similar systems of oppression, as documented by Dr. Safiya Noble in her 2018 book. All right, so what are we going to do about this? Well, risk mitigation strategies all start from considering our research time as a valuable resource to allocate carefully. That means at the start of a project, thinking about what are the best ways to do what I'm going to do, and also to support people building on my work. And this includes incorporating energy and compute efficiency in planning and model evaluations. It includes selecting data sets intentionally. And here we are very inspired by Birhane and Prabhu's words after Dr. Ruha Benjamin. Feeding AI systems on the world's beauty, ugliness, and cruelty, but expecting them to reflect only the beauty is a fantasy. Doing this work carefully also means documenting our processes, our data, and our motivations, and keeping in mind potential users and other stakeholders of our technology. That will allow us to do pre-mortem analyses, considering worst cases and unanticipated causes of those worst cases, and adopting other methodologies from value-sensitive design to identify the stakeholders and design to support their values. We need to ask, though, if we're telling people to back off from this path of large language models, are there risks to that? What about benefits of large language models like improved auto captioning? Well, to that we ask, are large language models in fact the only way to get these benefits? What about for lower resource languages or situations where you've got time or processing constraints? Well, in fact, what we find in the speech recognition literature is lots of work already on working with leaner systems because large language models are in fact not always practical. If we are using large language models, are there things that we can do to mitigate the risks of them being out in the world, such as watermarking synthetic text or coming up with good policy approaches to effectively regulate their use? So finally, we would like to leave you with the same set of questions that we started with. Are ever larger language models inevitable or necessary? What costs are associated with this research direction, and what should we consider before pursuing it? Do the field of NLP or the public that it serves in fact need larger language models? If so, how can we pursue this research direction while mitigating its associated risks? If not, what do we need instead? Thank you for your attention.